Good morning, friends. So let's get started. I hope you guys can hear me, and also I'm sharing my screen. Uh, and Please confirm that you guys can see my screen. Let Okay, thank you, Jiva. So let me go back to the agenda. So as of now, we are talking about data frames. So far, we have started with setting up the development environment. We have seen MapReduce overview, HDFS in detail, Spark with Scala as well as Python. We have seen Hive, Scoop, and overview of HBase. And as part of the data frames, we have seen how to create a data frame and what are the basic operations on data frames using data frame API. Now we'll be getting into data frames using SQL. So earlier, if you think about pre-Spark 1.3, Spark SQL runs in completely different manner. There was no data frames at all. When you try to write a Spark SQL, if it is a Hive, if you are trying to query the Hive tables, it will compile into some Spark native code, and then it will be executed. Now they have created this layer called data frame, wherein you can query Hive tables, and the underlying implementation is same as using the data frame operations. So data frames are the ones which will differentiate the structure and the processing. Okay, so you create the structure using data frame, and you process whatever API you want on top of the data frame. Internally, it uses the data frame API to actually process the data, depending irrespective of the framework you are trying to execute. So let me give an example here. So here, as I have demonstrated as part of our previous class, we need to create a case class first. And once the case class is created, we can apply transformation using map function, and we can create a data frame using the case class. So orders is a case class here. So once that is done, once the data frame is created, you can use either the data frame operations or Spark SQL on top of it. And the data frame can be created in multiple ways. One, by applying the map transformation like this. Other, if you already have a structure in Hive Metastore, you can create a data frame out of Hive table also. So we'll get into that as part of the Hive in Spark context in a while. First, we'll talk about data frames and using SQL on top of that. And a data frame can be created using transformation such as map, or using Hive Metastore also. Okay, so the steps are similar until here, until you create the data frame. And instead of using data frame operations, if you want to use SQL, you can actually register a temp table on the data frame object, and then we can use SQL context.sql and write the query. Okay, so I will demonstrate now. So here I'm trying to log into the CloudX lab. We can do it using the STS also. And if you follow the instructions here, it will actually give details from the STS or Eclipse with Maven plugin and SBT. So you can do either way. In this case, for the demonstration purpose, I am using the CloudX lab. I'm logging into the CloudX lab. Once I log into the CloudX lab, okay, I have to stop this. I will take care of it later. Otherwise, I will be getting these notifications. Okay. So once we get into the CloudX lab, we can launch Spark shell. Or PySpark also works, but the syntax will be a little bit different. I'm only covering from the Scala perspective. It is still coming up. We can also try data frames and SQL on data frames using plain Spark installation also. So I have Spark installation on my PC also. So I can launch Spark Shell like this. As of now, I am on in my PC. This session is in CloudX Lab. Okay. So this is my Mac. This session is on my Mac, and I have set up Spark as I have demonstrated earlier, and I can launch Spark Shell from here also. In case if it takes too long, I can actually demonstrate using my local native Spark installation. Anyway, it came up now. So let's use CloudX Lab itself. Okay, so first thing you need to do is, first thing you need to do is you have to import several things. You don't need to import Spark context or Spark comps here, because Spark context and Spark configuration objects are already created when we launch Spark Shell. So we don't need to worry about these two import commands. And then we can create a case class. So as you guys are already familiar, orders have 4 columns: order ID, order date, order customer ID, and order status. Order ID and order customer ID are integers, and order date and order status are strings. Okay. We don't need to create the configuration object and context object, but we have to create a SQL context, because SQL context, let us see the type of SQL context now. So when we launch Spark Shell, this SQL context object is also created. So let us see the type. It's a Hive context object, and we don't want to query the Hive tables. So we'll change the type of the SQL context. Okay, so here what we can do is it's already imported org.apache.spark.sql. So I'm just replacing the SQL context. And now if you see, this SQL context is nothing but org.apache.spark.sql.sql context. Earlier it was Hive context object. Now we have created SQL context object. Okay. And then we can set the configuration parameters like this. I will come back to the significance of this in a moment. And we need to import this one. If we don't import, then some of the functions will not be available. Especially this 2df function will not be available if this implicits are not imported. So implicits have several other APIs which needs to be imported to use as part of the data frames. So you just remember that we have to import implicits of SQL context, and implicits have several nested APIs, and we have to import everything under that. That's why we are using underscore here. So let's copy paste this one. And then first we need to load the data. So let's load the data using sc.txt file. We need to use correct input path. The correct input path is this is the one. So this is the path from which I want to read the orders data. Okay. So I copy that path, and here I'm trying to create orders data frame equal to sc.txt file paste this path, and then I have to use the map function. As part of a single line code, I am actually reading the data using sc.text file and then applying the map function to create the data frame. Okay, so rec. I think I have to write in multiple lines. Yes. So here I am creating a object called A. Okay. So I'm applying rec.split using comma as delimiter. As demonstrated as part of the next last class, this rec.split will create an array, and A is nothing but an array of strings. And each for each record, this split will be applied. So there will be 4 values in the array with name A. Okay, and then I am trying to return orders object for each of the this record, and first I have to get the first element, and then I have to convert into integer, and then second element is already a string, so we don't need to worry about it. Third element is again of type integer, and fourth element is again string. Okay. Okay, so this is the what we are trying to do is we are trying to apply the array into this orders object, case class orders object of orders of type case class. So again, let us refresh what is case class is. Case class is nothing but a plain old Java object, similar to a plain old Java object, wherein we don't need to explicitly specify setter and getter methods. So there will be setter and getter methods automatically created for this orders class, and also as part of Scala, there is a concept called apply function. So if we specify new, it will invoke the constructor. If we don't specify new, it will invoke the apply function. And as part of the apply function, it will invoke all the setter methods. So what does this mean is, if you are familiar with Java, it is actually calling a method called apply, and that apply method will call the setter methods using the values that are passed. As there are 4, there will be 4 setter methods, and all those 4 setter methods will be invoked in that apply method, and that's how the orders object will be created for case class orders. Okay, so again, you need to understand the difference between class and case class, and if you are not familiar with Java, then you will have a little bit tough time to understand. But bottom line is, when we define as case class, even though we are specifying only 4 attributes or 4 variables, internally there will be getter methods and setter methods. So getter method is to get a value out of the object, and setter method is to set a value in the object. So there will be default getter and setter methods, and also on top of that there will be a method called apply, and that apply method or function is being invoked when we call it like this. Here we are not trying to invoke the constructor. Instead, we are trying to invoke the apply function. Okay, even if you create a regular class, and if you define getter methods, setter methods, and apply function, still you can call it like this. Either you have to create a case class, or you have to create a regular class with getter, setter, and apply function, and automatically when you call this one, it will call the apply method, and whatever functionality you have given in the apply method will be used to and typically we will be invoking the set methods for each of the variable, so that we build the object, and then we are creating the data frame by using 2df function. Okay, I think there won't be any setter method will be created here because by default case class parameter is val type. I'm not sure. As per my understanding, case class is nothing but variables with getter and setter methods and an apply method, and that apply method will be invoking uh, the setter methods. So here you here these are not of type val. I'm not 100% sure on that. I will cross verify and I will let you know. Okay, but internally that's what I understood with case classes. Okay, anyway, so bottom line is you just create a case class and invoke um, uh, uh, the case class like this, and pass the parameter values. So there are 4 parameters, hence we are actually passing 4 values from the array, and then we are creating the data frame. And then we have to register template table. So the register temp table has to be invoked on the data frame object, and the name which we can use has to be passed in the double quotes. Okay. Now we can, as part of the SQL context.sql, we can query the data from this table. Okay, so we can say SQL context.sql, select star from orders limit 10. And you can see, I think I need to, yeah, I need to use for each. So for each, println. So input path does not exist. Okay, I have copied from the wrong location. So here, what I have to do, I have to fix this one. So the location is, I copied from the local path instead of copying from the HDFS. In HDFS, the data is under I think there is a subdirectory called data in it. Let us see. Okay, let me copy this in case I have to paste it again. Okay, now I am running SQL query again. Again, the path is incorrect, that's why it failed. Here I have to use data. So this is my HDFS location. And now paste. And now run the query. Still there is some issue. Okay, I know what is the issue. Okay, out of df. And then I have to use the register temp table. Yeah, now it will work. So now you can see the data. Okay, so this is how you can actually create the data frame and then run queries against the data frame. Okay, now let us go back to our original problem statement and let us try to get total revenue for each day. So in this, if you think about it, orders have the order date, and order items have a column called order item subtotal, using which we can compute the revenue for each day. So we need to apply the filter condition, we need to apply the group by, and then we have to use aggregate function, and then we can see the results. So first, what we have to do is we have to create a case class called orders and a case class called order items, like this. Order items have 7 fields. Okay, order item ID, order item order ID, order item product ID, order item sub quantity, and order item subtotal. And orders have 4 fields. So we have to join these two, get order date, and the order item, perform group by function on order date, and apply some aggregate function on order item subtotal to get the total revenue for each day. So here, let us create orders df and order items df. Orders df is already created, and also we have registered temp table, so I'm not doing it again. Now let us do it for the order items. Okay. User training 8634 data retail underscore db order underscore items, and then apply the map function the same way what we have done for the orders. I'm using rec.split to create an array and assigning the elements from array into the order items case class, and then we are invoking 2df function. So then we have to register temp table. I think I'm in the I'm in the right one only. So this is how you can actually do it for regular data frame operations. And if you have to do it in SQL, you can do it like this. Okay, so we have to register temp table for order items. Once you have both orders and order items data frames, either you can actually use data frame operations. So as I have demonstrated as part of my last class, you can have orders. You can invoke a filter function on orders df or data frame, and then apply the filtering like this. You can do the join, and if you want to do, you can do the aggregation also, group by ag sort rdd sort. And then if you want to save the output to an output path, then you have to convert it into rdd, and then you can invoke save as text file. So this simple code is by using data frame operations. And if we have to do it in SQL way, once we create a data frame for orders and order items, we have to register as temp tables, and then we have to invoke SQL context .sql, and in that we can pass the query. So this query have the join between orders and order items. It has the on order ID and order item order ID, and then it has the filtering condition. Because we are only considering completed orders, we don't care about the other orders to compute the total revenue. And then group by order date, and as part of the select clause, we are invoking aggregate function called sum, so that we can actually get a daily total revenue. And in the end, I want to sort it by order date, hence I am using order by. So this is the query to get the total revenue using data frames SQL. And then if you want to save the output to a output file, we have to convert a data frame into an RDD, and then we can invoke save as text file to write into a output path. There are other ways also. For example, Let me run this query first. Okay, now total revenue daily have the output, which have the order date and some derived column called underscore C1, which is nothing but the total revenue. If you want, you can give the alias here to get appropriate column also. As we don't have alias, it has created a derived column here. Now you can say total revenue daily collect for each interval. Okay, so now we get the total revenue for each day. So it took a lot of time. There is a reason for that. And if you closely observe the logging information, it is creating 200 tasks to finish this job. And we hardly have few megabytes of data, and it is creating 200 tasks. So it is using too much of resources to finish this query. That's where the set conf comes handy. Okay, so here by specifying Spark SQL shuffle partitions, by default it is 200 when you are trying to use Spark SQL. If you want to play with that to improvise on the performance, to bring efficiency in the execution, you can override that value of that parameter using SQL context dot set conf. So now we will run this. And then we will try to apply the collect function. Okay, I think I have to run all the queries again. Okay, I think I have to create the SQL object. I think I have to run this one. Let us see if that is enough. Otherwise, we have to run all the comments again. Yeah, now you see it is much faster because it has created only 2 tasks. See here. So that is the significance of where is that? SQL context dot set conf Spark SQL shuffle partitions. So we use this not only to play with the number of partitions, but in several other scenarios wherever you have to override certain parameters, you have to use this set conf function, and you have to override like this. Sometimes we override at SQL context, sometimes we override it at SC Spark context. I think Spark context have a method called set, and in the set method you can override certain parameters. But when it comes to dealing with Spark SQL, typically we use SQL context dot set conf method. Okay, so this is how you can actually write the query, the supported queries after creating the data frames. And also on top of data frames, instead of converting to RDD, you can also see there are several other functions such as save as Parquet file, save as table, schema, etc. So output can be saved into different formats. But if you want to write into output files the way we have done earlier, then you have to convert into RDD, and then that RDD can be saved into text file. We can use all the available functions on top of RDD to do whatever we want. And save as text file is one such method where we can actually copy data into text files. You can also convert it into JSON if you want by running two JSON function. So you need to be familiar with as many functions as you want. But when you are using Spark SQL, we don't use data frame operations such as filter, first, and group. There are several others. So you can go to here and see the example. Group by ag. If you want to aggregate, you can use ag, and then you can invoke the aggregate function. You can sort the data, and you can do whatever you want using this data frame API. Okay. And now we'll get into Hive. So let us see. First, we need to make sure that we have Hive tables, orders, and order items to demonstrate the Spark SQL in Hive context. Okay. Now I have to go to Hive. Okay. Now if we say show tables, there is orders and order items, right? 1 minute. Let me make sure that people can see my screen. Yes, that's good. Okay. So we have tables, order items, and orders, and we have overridden the session. SQL context is now pointing to Spark native SQL context. We have to change it to Hive context. So I'm creating a variable called SQL context here, equal to arg.apache.spark.sql. Hive dot Hive context. Okay. I have to say, I have to invoke the constructor new sc. Okay, now it has connected to Metastore. If it does not if it cannot connect to Metastore, then you will not be able to run the Hive queries. Okay, it is using the thrift service to connect to the Metastore. It is taking some time to get back the control. Let us wait until we are back to the prompt, and then I will demonstrate. So if there are any issues at this time, if it fail for whatever reason, then you will not be able to run queries against Hive tables. Okay. So here I'm showing how to create the tables and load the data if you're coming here for the first time. And once the Hive once the SQL context is created with the Hive context, then we can run queries directly. We don't need to create case classes and all those things. We can just say Hive SQL context dot SQL and then select star from my database name, which is training 8634 dot orders limit 10. I hit enter accidentally. Dot collect for each println and hit enter. Now you can see the data directly from the Hive table. Unlike earlier, we are not actually creating from the or querying from the native orders. Okay, even though the template table is registered with the same name of orders, here I am prefixing with training 8634, which is going to my Hive table and getting the data. Okay, uh, and even if you have the table with the exact same name, as SQL context is now pointing to Hive context, it will go to the Hive metastore and it will try to fetch the tables. It will not try to access the uh, local tables. Okay, local tables which are created using registered temp table as part of the earlier steps. So you can run queries directly like this, or you can create a data frame on top of it, and you can perform the data frame operations also. So internally, when you run queries like this, it uses the data frames itself. It does not query directly. Okay. All the queries will convert it into data frame APIs, and those data frames APIs will be invoked to get the results for you. So now by dividing the processing, by separating the processing with the structure, Spark is trying to give flexibility for the users to use whatever framework they want to access the structured data. So data frames is the layer which facilitate that, and data frames is not new with Spark. It is there with programming language such as Python, R, etc. Okay. So now if I have to just join, I can directly say whatever query we ran earlier, the same query will work. Only thing is we have to prefix with training 8634. Or we can also say, yeah, we have to prefix with training 8634. So I'm opening Sublime Text. Okay. Well, total revenue daily. I'm trying to create an object here. Okay. Now you can see the total revenue daily is nothing but data frame. And then we can say total revenue daily dot now again you can see it is going to 200 because the earlier setconf which we have applied is on Spark native SQL context, not on Hive context. So we have to again set that method. So SQL context dot setconf. Again, I have to run the query. That's why it is running. It is using all 200 tasks again. So let me run this query. It is very important for you guys to actually understand the logging information which it is providing, and you need to have a look at the way it is using the resources, and then only you will be able to figure out it is working effectively or not. Okay, now we can actually now you can see the results much faster. Okay, so this is how you can actually invoke queries on Hive tables using Hive context without creating case classes, etc. Okay, so you can go through this and you will understand several other options. You can you can drop the table, you can create the tables, you can load the data using SQL context.sql as long as the SQL context is of type Hive context. How to read data from external databases into Spark SQL, for instance, from MySQL to Spark SQL. Yes, so I will show that. Let me launch STS. It's pretty simple. You just need to use JDBC, Spark with JDBC. So whatever I have shown, again, you have to follow the development best practices. You have to externalize the paths and all those things the way we have done earlier. So in this case, to answer Jiva's question about how to access data about JDBC, so this is how you can do. You have to create SQL context object, okay, and then in SQL context there is a read dot format function, and there you have to pass the JDBC and you have to give the options. You have to give the JDBC URL, you have to give the table, and then you have to invoke the load function, and then we can access. So I will demonstrate here. Okay, first we need to change the SQL context. Well, let me create a new one. JDBC context equal to org.apache.spark.sql. Okay, then well, departments JDBC df equal to SQL context. Sorry, JDBC context dot read dot format JDBC. Okay, and then we have to use the options and then map URL. So we are creating a map, and we have to pass the map, and depending upon depending upon the database you are trying to connect, the parameters might change a little bit. That's why they are asking us to pass map. And in this case, to connect to MySQL, we need to have the URL with JDBC username, sorry, host name, database name, username, and password, and then that DB table departments. So URL can be built like this. So it can be like this: JDBC MySQL // and then I have to get the So this is my internal port number 3306, and then database name retail underscore DB, and then user equal to retail underscore DBA, and password equal to IT Varsity. Okay. Then DB table, whatever table name we want to read. So in this case, I am trying to read departments. Okay, so there is an issue. Value read is not a member of object. Okay. Yeah, here I have to use the constructor. That's why it failed. Okay, now I can actually. Also, we need to point to the MySQL jars. In this case, we haven't, so it might fail. Let us see. So it is failing because no suitable driver found. So we have to uh, we have to set the path to our MySQL jar files. So the way we can do it is exit Spark shell, so this is the one, driver class path. You can even set within that session also, but I do not remember on top of my head at this time. So I'm using user share Java MySQL connector java.jar. Oh. It is taking long time to connect to Hive Metastore. Okay. Now I'm creating JDBC context pointing to SQL context, Spark native SQL context, because this SQL context is a Hive context. Now I'm running. Still it is failing. No suitable driver. Where is the typo? There is no typo. JDBC MySQL 3306 return underscore DB user return underscore DBA password. Let me see. Yeah, retail underscore DB is the database name. Retail underscore DBA is the username. Yeah, you have to give that because we are passing the username and password as part of the string itself. We have to give that. Otherwise, it will not work. So, host, I'm just cross verifying JDBC MySQL colon slash slash host, host name, port number. We can actually try. Let us see. IT works. It is the username. It is working. Okay, it is working. I just need to confirm that this driver class path is correct or not. Okay. I think I should not give equal to. Did I give equal to here? Yeah, let's try without equal and see if it works. Otherwise, we will wrap up and we will look into it later. So I'm exiting and now I am removing equal here. I also have in my GitHub account. Let me check my GitHub account. Um, yeah, I think I should not have equal. So it's still coming up. Let's wait for a moment. Oh my God, it's taking way too long. I hope you guys are practicing using CloudX Lab. Okay. Still failing. Again, it's complaining on the same thing. Oh, yeah. Thank you. It should be JDBC column MySQL, not dot. Okay, now it's a different error. It is talking about username and password. Why it is giving this error? I will show. Uh, Password is okay. Typo again. Sorry for that. Yeah, now it will work. Now it is creating the data frame object. Now we can do whatever operations we want the way we want. Either you can we can use tradition the data frame operation directly on it, or we can convert it into RDD and we can do whatever we want. So this one I'm trying to demonstrate to print by applying the collect operator for each print ln, and you can start seeing the data. I'm not sure why it is showing D001, D002, etc. Someone seems to have messed up with the data in the table. Okay, so there is a question from Jiva. Could you show how to set the MySQL connector in the session itself? Okay. Set Spark Scala set DB class path. So I will have a look at that. But if you want to do it programmatically, so more than setting within the session, more important is about how to build the application using that. So for that one, what you have to do is, so now I am going to the FBT package, FBT, and I will show you how to package. That is more important because you have to build the application that way. So here research, R&D, and then big data Spark Scala. Okay, if you look into the build.sbt, this is how you have to update the library dependencies. And once you update the library dependencies, and once you run sbt package, then you will see the MySQL related stuff as part of this. You can see here MySQL connector Java. So depending upon whatever version you have mentioned here, that one will be automatically downloaded, and you will be seeing in referenced libraries. Okay, so this is how you can actually take care using SBT while developing the applications. How to do it in the session, I'm not 100% sure. There should be a set parameter for that, and then you have to override that parameter, and you have to pass the class path of the, what is the parameter? Let me exit. Driver class path. You have to identify the appropriate parameter for the driver class path, and you might have to set it to make it available as part of the Spark Shell session itself. However, that is not that important. More important is to understand how to create the dependencies as part of the build.sbt. I'm not sure why it is not opening up here. Okay, F5. Yeah, so you can see it here. So this is more important. Okay, so once you have once you are able to establish the JDBC connection and start running JDBC queries, you can actually do whatever you want as part of the downstream processing. So let me copy paste this one for you. So that is the JDBC code snippet, and this is how we started the Spark Shell. And this is the latest SBT, build.sbt. So I will update my blog. I'm primarily focusing on the lab. That's why it is taking a lot of time. I'm not working too much on the content these days. Once the lab is set up, I will accelerate and I will try to update the website so that you have all the necessary information here itself. Okay. So that being said, that's it about Spark SQL. We have covered data frames, data frame operations, data frame SQL, and also Hive in Spark context, and also we have covered JDBC SQL. Sorry, Spark using JDBC. So let me give the code. Okay. So I will, once I have it in blog, you will see everything over there. For now, you can use this one. And again, it's very important to externalize and make sure that these values are replaced at runtime rather than hard coding as part of your code. You use the type safe config package and externalize all these database related details and replace at runtime to connect to the appropriate database from the environment to the environment using which we want to get the data from. Okay, so that's it about Spark. We have covered Spark with Scala, Spark with Python, and Spark data frames using Scala as a programming language, and we have seen data frames and operations on the data frames. SQL on data frames, and also Hive, and also we have seen JDBC. That being said, if you have any questions, I will take those questions for now. Otherwise, we'll move on to the next topic, Flume and Kafka. So what is the difference between data frame and data set? So I still didn't get a chance to look into that. I will have a look at that and I will get back to you. Dataset is relatively new feature. We started with 1.6.2, and they are trying to get into data sets more than data frames going forward. And I have to have a look at that. Yes, Raj? You can ask the question. Okay. Yeah, so Hive videos are online. It is not in the in the blog, but they are online. So only one video I am missing, and that is 1 minute. I will give you the details. So if you go to this playlist, I haven't updated the blog. I will take care of that today. But all the videos are available. Only one video, the screen is not captured. That is, I think, this one. Big Data Engineer Immersion Class 17. Okay, even this one, the screen is captured.
Okay. So what this query is, you can run any valid query.
So you can have a look at this one. Yeah, all the videos are there in the playlist. I didn't update the blog. I will take care of that today. Actually, what happened is I updated the blog, but there was an issue with my blog, and I have to restore with a previous backup. That's where these videos from the blog are lost. Okay. So you can follow these videos and you can let me know if you have any questions. So any other question before we move forward? Okay, so next question is, could you say something about check style, Scala test, Scala check, etc.? I'm also not very sure about those things. Probably Scala test might be a testing framework of Scala, and I'm not sure about check style or Scala check. I haven't explored yet. Okay. So yeah, you can safely say that you are not aware of those things. It's not that they use in almost all the projects. They might be in the desired skills, they might not be under the required skills. Scala test might be a testing framework. So if you are aiming for, you can actually give me the link in which they are asking these things. And we cannot cover all the combinations that are available from all the job descriptions. Okay, and we have to explore certain things ourselves if they are repeating. I have created the content which match 70 to 80% of any big data engineer profile. So first, show me the provide me the links in which they are asking about these check style, Scala test, Scala check, etc. If they are relevant for the big data engineer, I will try to cover as part of my future sessions. Okay, but if they are Scala have non-big data related portions also, you can develop end-to-end web application using Scala. And these things might be more relevant at the time than big data engineers. As per my analysis, most of the big data engineer persons does not have these details about check style, Scala test, Scala check, etc. They might be in some of the Scala based web development job titles. Okay, anyway, send me the job description, I will have a look at that. So any other question? Okay, let's move on to the next topic, which is Flume and Kafka. Again, I haven't updated the blog completely here, but I have the content already. I will showcase from there, and then I will try to update the blog at the earliest. So that one is, if you go to the certification courses, and if you go to CCA 175, you can see the data ingest using Flume and HDFS. Okay, so you can go to this for now to get the material about the Flume. It doesn't cover Kafka, but it covers Flume. It will give you an overview about Flume. Again, we will not get into too many details with respect to Flume. We will just cover overview and try to understand the relevance of the Flume, and try to get data from weblogs into HDFS using Flume. Okay, so if you are following my course, we have to get data from multiple sources. One of the source is database. If we have to get data from database, we use Scoop, which is already covered. Sometimes we get data to file servers, and from file servers we have to copy into HDFS. For that, either you can use Hadoop FS -put commands, wrap them in shell script, or you can you have to use Hive commands such as load to load data into the Hive tables. So either you can use Scoop to get the data from the databases, or you can use Hadoop FS commands or Hive load commands to get data from file servers into HDFS. And the third type of source is weblogs. The weblogs will be refreshing at consistent intervals. Will be refreshed regular. Sorry, the weblogs will be refreshed regularly, and we have to capture the data from the weblogs, and we have to channel the information from the weblogs into some target. It could be HDFS or it could be anything, but most frequently we tend to copy data into HDFS, but it could be others also. So the more the prominent tool which is used to get the data from web servers and load the data, get the data from web server logs and load the data into target systems is Flume. So Flume has the capability of polling the weblogs at regular intervals, get the data, and you can create a channel. A channel can be memory channel, file channel, or Kafka channel, and then point to a sink, and the sink will be storing the data into HDFS. This is the high level architecture of Flume. Okay, so there will be agent that will be running, and that agent should be able to connect to the source and also to the target. And source is typically web server logs, and the target is typically HDFS. Okay, and the channel can be memory. So the way it communicates between the source and sink is through the channel. It could be memory, it could be file, or it could be Kafka channel. We will see those details as part of the session as we move forward. And again, if you have to read the documentation, you have to start with Flume user guide. The way you have the way we have used the Scoop user guide, we have to be familiar with the Flume user guide also, because that is where the official documentation will be available. And here you don't need to worry much about setup. Okay, the main things which you need to look into or Flume sources. You can see that data can be read from Avro, Thrift, Exec, Twitter, many other sources. And you have sinks. Sink can be HDFS, Hive, Logger, Avro, Thrift, and many more. And then there is a channel. Channel can be memory, JDBC, Kafka, file. It could be anything. Okay. So as part of the this overview, what we will do is we will try to cover exec source, where we can actually get the data from the streaming weblogs. And also we will see something called netcat source. Netcat source is primarily used to explore or learn Kafka, sorry, to learn Flume. Okay. And then as part of the sync, we will see HDFS sync and also logger sync. Again, logger sync is primarily for the exploration purposes. We don't use it in the production. Netcat is also will not be used in the production. It is primarily to explore and learn and understand the Flume architecture and also Flume capabilities. And then as part of channel, we will see Flume channels. We will see memory channel, that is the main one, and also the file channel. And also we will, I will give a overview about Kafka channel. So we are planning for a small workshop on the Kafka, where we will get into hands-on stuff. As part of this session, we will only see the theory, means as part of the next class within the course, we will see the theory of the Kafka. But we will demonstrate the memory channel and file channel to get data from streaming weblogs into HDFS. Okay. That being said, to kickstart, what we have to do is we have to create a configuration file which look like this. Okay. So you can copy paste this one. mkdir Flume demo already there. Here you can see the example, and in this example.conf, we just copied whatever is here to here, and this is primarily done to explain how the configuration file is created. Okay. So any Flume agent is a combination of source, sink, and channel. So we started with source, sink, and channel. And here, if you see, we have given a name called A1. What is that A1? So A1 is the agent name. So when we try to start the configuration, the agent with the configuration file, we have to pass the agent name. For example, to invoke this one, here we have to use flume-ng command. Agent is the command to start the agent. -n is to create an agent with a name, and whatever name we give here, that should be used here. So to run this one, we have to say flume-ng agent -n A1, and then we have to pass the configuration. We will get the details about this little bit later. So whatever we pass it here has to match it over here. So the notation of our configuration values are for each and every configuration value, the name will start with the agent name. So agent name is A1, and here we are giving a name to our source. The source is called as R1 here. So A1.sources. So the source for the A1 is named as R1. The sink for A1 is named as K1. The channel for agent A1 is named as C1. So first we have defined the names of the components of the agent A1, which are R1, K1, and C1. And then we have type. There are n number of types for sources, n number of types for channels, and n number of types for sinks. So here we are trying to define the properties for each of these components one after the other. First, we are dealing with sources. So as part of the sources, first we are defining the type. The type is netcat. I will explain what is netcat when we run it. And when we actually start this agent with a netcat type, it will start a web server. And that web server IP address has to be bind using r1.bind. And to get these values, to get these parameters names for the source or whatever component we are dealing with. So in this case, we are talking about source. So we have to go to the Flume sources, and we are talking about netcat source because the type is netcat here. So click on that netcat. Okay, where is that? So Flume sources. And netcat, and you will get to the netcat source section, and here you can see all the parameters that are available for this, and the bold ones are mandatory ones. So when you want to define a netcat source, you have to define a type, bind, and port. Others are not important, or others are not required properties. They are only optional properties, and you need to understand each of these properties before you use them as part of your agent definition. Similarly, if you go to XX source, so that will be another source which we will be using. So I'm actually showing different properties for XX source. So here type and command, these two are the only required parameters, and then you need to understand the other parameters or properties to use as part of your agent configuration. Okay, so as we are using netcat, the three mandatory properties are type, bind, and port. Bind is the IP address on which the netcat web server will be running, and port is the port number on which it will be running. And then sync, we are trying to use logger. Logger means it will try to log to the server to the same server from where we are trying to read the data. Okay, in this case we are trying to read the data from the netcat, and then it will be we are trying to define the sync as logger. And okay, and logger is actually, it will try logging into the agent logs. So when we actually start Flume agent, you will see a web server running for the agent itself, and we are trying to log to the logger agent. Agent logger. You will understand when I actually run this agent. And then channel, again, to understand what properties you should use, you have to go to the sync here. So I'm trying to use logger sync, and when it comes to logger sync, only mandatory parameter is type, and then there are other parameters or properties. If you want to use them, you need to understand those things, and you have to start using those. But for logger, you don't need to worry much about the other property, which is max bytes to log. We can leave it as default. So here data will be read from the netcat web server, and data will be returned to the agent logs. You will understand when I actually run the agent. And then channel. So again, there are several types of channels. We will start with memory. We will also see the file channel. So again, you have to go to the documentation, go to the channel section, and go to the memory channel. Only type is mandatory, and there are other properties such as capacity, transaction capacity. You have to make sure that you use appropriate values for capacity and transaction capacity. So capacity will control how many number of events are stored in the channel, and transaction capacity is how many events it will take from a source or give to a sink per transaction. Okay, so capacity, how many can it store at a given point in time, and transaction capacity is how many it should read from the source, or how many it should give to the sink. Because channel is the connector between the source and sink, this transaction capacity plays a role about how much should be read at a time, and how many should be written at a time to the sink. Okay, so here we are using capacity as 1000 and transaction capacity as 100. And then you can see here, these are all pretty straightforward. These three properties are related to source. And the way we have defined the properties is A1, which is agent name, dot sources, which is a keyword, dot R1, which is the component name, dot property of that component, which is type, bind, and port. Similar is the case with sink, similar is the case with channel. And then we have to connect the source and sink with channel. And this is how we do that. Agent name dot sources dot source name dot channels. Which channel we want to use? C1, which is nothing but memory channel in this case. Similarly, we have to define for the sink also. So these two actually bind the source and sink to the channel. Okay, so this is the basic architecture of Flume agent. Once you have this, what you can do is you can say Flume -nv agent -n or -- name. You can do either way. A1 is the agent name. So whatever you have used as the first string as part of the names before the dot, which is the delimiter in the names, that has to be passed here. Otherwise, it will not work. And then the syntax is, let me do this. Instead of searching in the documentation, we can actually say Flume -ng, and we can see the details about the how to start the Flume agent. So Flume -ng agent is to start the agent. -n or -- name to give the name. So in this case, it should match with whatever we have in the configuration file, which is A1. And then -conf or -c is to give the configuration directory. So in this case, it is home training 8634 Flume demo example. This is the configuration directory, and configuration file is example.conf, and run it. So it will start two web services. One is for the Flume agent, and as our type is netcat, it will start another netcat agent. So here the address is already in use. So let me use something else. Someone might be running. This is a shared location, so someone might be running already. So you have to give a port which is not being used. So now it has started source, it has started sink, and also it has started channel. So we will go to the another tab. And log into the CloudX lab. And here you can say MC localhost and then the port number. And then as long as the web service is running, this will hung like this. And then you can type, hello world, how are you doing? And you can see the data is coming here. So it has, from source, the data goes to the memory channel and come to the sink, and this is the logger. Okay, so when the agent is started, it also starts the netcat web service, and due to which we are able to run this command called mc. This is the IP address and this is the port number on which the netcat is running. So we have to give that IP address and port number, and whatever you type, it will be read by Flume agent. Channel is through channel, and write it into the sync, which is logger in this case. And you can see the logging details here. So we can kill this session by hitting Control C. You can also say telnet. If telnet is installed, you can also use telnet localhost port number. Telnet is not there here, so we cannot use telnet, but you can use nc. Okay. So this is how you can validate your first Flume agent. Here I'm trying to cover how the naming conventions are used while creating the Flume agent. I hope you understand that, and also we have tested the basic configuration of getting data from web server, which is nothing but netcat in this case. Configure a simple memory channel and get the data into the sync, which is logger. And we will actually get into a little bit more complex example in which we will actually get the data from streaming web logs and then write the data into HDFS. For that, Cloudera provided a tool called gen_logs, and I requested Cloudex Lab guys to set it up as part of the environment, and they have done that. So when you run this gen_logs.sh script, or gen_logs, okay, they should have this one. Sorry, start_logs. Yeah, start_logs.sh. Yes, this is the one. So gen_logs is the utility name, and the command is start_logs.sh. It will start generating the logs. You can say tail_logs.sh, and you will see the logs being generated. So these are streaming logs. So we will try to get the data as long as the logs are being generated, and then we will try to see how this data can be stored in HDFS. Okay, and if you want to stop, you can run stop_logs.sh. It will. Okay, they did not give you the permission to stop. Probably they just keep on running the logs, or someone might be warning the session which is generating the logs, limiting our capability to kill. But as long as the tail_logs is generating the logs, you can actually use tools like Flume to get the data from the web logs and channelize through memory channel or file channel or Kafka channel, and then write it into the target. And if you want to perform certain analytics, you can use tools like Storm or Spark streaming to process the data before loading into the desired sync. It could be HDFS, it could be some other database also. Sync need not be HDFS all the time. It could be anything. Okay. That being said, that's it for today. If you have any questions, I will try to address those things. Do you have any videos for analyzing Flume output using Hive? So Hive is nothing but SQL. Okay. So as long as there is a structure on the data, you can create a table on that data, and you can run Hive queries. Okay. So first you need to understand what is the format of your data and how you should make it accessible with Hive. If it requires some transformations, you have to use MapReduce or Spark, perform the transformations, and convert the data into a format on which Hive table can be easily created, and then you can use Hive queries on top of it. Okay, so it should be pretty straightforward. In this case, if you see, data is following a particular structure. So they are giving a IP address, and then I don't know what is this hyphen and this hyphen, and they are giving a date, and they are giving an API call which is being used. So this is the API call, and I'm not sure about these two values. And then they are giving from which browser data the request came in. Okay, so here it says it is from Safari. Here they say Chrome and Safari. I don't know why they have shown Chrome and Safari. They even have Mozilla. I'm not sure. We need to interpret this data, and then we have to take the necessary action. Okay, I think this is a standard message. I don't know. Probably this code might mean something. So we need to actually understand this data, and then we have to come up with the processing logic to process the data in such a way that we can use it as part of our downstream. So in this case, what you can do is, so you have the department, apparel, and categories. If you just want to search on which department most of the traffic is coming from, what you have to do, you have to, if you have to do it from the daily basis, you have to get the date from here, and then you have to pass this string. Okay, and it has /s delimiter because they are invoking a REST API called get on route called department, and then it has a sub route called apparel, and then there are categories in it. Okay, so if you just want to get what all departments are frequently accessed, you have to pass through this string. You have to extract the necessary information using Spark streaming or Spark core APIs, and then write the data back to a structure wherein you can define the Hive table. If you cannot define the Hive table, then you have to do processing using some other means. It all depends upon what you are trying to do. Okay, and then there are also get API calls. You can see that product and then product ID. So if you want to see which products are being accessed more frequently, you have to identify how the route is defined, and you have to pass the data, and based on that you have to store as per your requirement, so that you can do some downstream processing. Okay, so if records are more than one line, which file format we might use as part of SC dot, for instance, sc.txt file. So this is where you need to understand the HDFS or MapReduce file input formats. Okay, so there are several file input formats. And if you get into here, there is a fixed length input format, key value text input format, multi-file input format, etc. Okay, so by default, when you use sc.txt file, it will use text input format. If you use the sequence file, sc.sequence file, it uses sequence file input format. If you want to use other HDFS file input formats, for example, every 2 lines is a record. Okay, then you can use nline input format. And the way you can use nline input format is, if you go to here and go here, you have sc dot new API Hadoop file, and as part of the new API Hadoop file, let me get the syntax correct. So why there are two? Okay, let me go to my GitHub code. So this is how it will look like. This is save as. Yeah, even without save as also, it will look like this. New API Hadoop file, you have to give the path, and then you have to pass other parameters based upon the type of input file you are using. So for example, if you want to use the inline input format, you have to give the path and then comma. So the path is in this case it could be input path and then comma. 1 minute. Okay, so input format. Okay, new API Hadoop in file, input format, path, class. So here you have to give the format name. Okay, so you have to give the org.apache. Whatever it is, and then you have to give the path, and then you have to give the other details. It's a little bit tricky. Yeah, save as is pretty straightforward. Means I have in my GitHub code also. But if you want to use new API Hadoop file, it's a little bit different. Okay, so you have to explore these Hadoop based APIs. So, but if your record is, for example, in some cases, your records might have some records might be in 2 lines, some records might be in 3 lines. For that, there is no standard out of the box solution. What you have to do is you have to come up with a custom API format, a custom text input file, and then you have to start using it. Okay, so it all depends upon your requirement. And there are certain formats that are available already, and there are certain formats which are not available already, and for that you have to develop your own classes. Okay, so these are the things which are available as part of the Hadoop, and there are certain file formats which are available as part of the Spark, like JSON, etc. So if none of these things can solve your problem, then you have to develop your own. So any other question? I hope I answered your question, Jiva. If you have any follow-up, I can answer that. Okay. Okay, then that's it for today. So as part of the next class, we will continue on Flume, and I will give you an overview about Kafka, probably, and also I will give you an overview about Uzi also as part of the next class. And then there will be one class this week, and probably a couple of classes next week, which I will extend to cover how to build the Hadoop cluster. I will be demonstrating from scratch how to come up with the cluster. Okay, so it is getting into the 9th week, and then next week will be the last week for the course. That being said, thank you very much. Bye. And whoever is on the Hangout, thank you very much for joining the session. We will catch up as part of the next session. Thank you. Bye. Hello, Skandar. No, this is not for MS students. This is for regular students. For MS students, the session is on Monday, which is Monday morning India time, which is Sunday night. This week it is cancelled because of the Diwali, but the session will be on Monday morning India time at 6 to 7, whatever is time in US. So labs, I'm working on the labs. So as I have been publishing on my LinkedIn and Facebook pages. We have made some progress. So November 3rd or 4th week, we will be giving limited access for few people. The full lab will be available probably towards the end of the December or January. Okay, until then, either you have to go with CloudX Lab or you have to go with your own environment. But if you are interested, I hope you have filled the form. Let me share the form with you. If you have not filled the form yet, please fill this form. No, it will not be same as AWS. It is different. You will have a multi-node cluster where you will have access to, and it's only big data lab as of now. And it will be 8-node or 9-node cluster, and it will facilitate you to prepare for the certifications, to practice, and there will be fixed cost unlike AWS. For students, I'm thinking about $75 for 2 years. For working professionals, it's $55 for 6 months, $55 or $60 for 6 months. Okay, and when I say 2 years for students, up to 2 years. So if you are already in second semester, it will be approximately 1.5 years. If you are in the third semester, it will be only 1 year. So as till you finish your MS and get your job, I'll be giving access at lower cost for MS students. Okay, that being said, thank you very much for attending the session. If you like this video, please click on the like button. If you want to provide the feedback, once the streaming is done, you can provide the feedback using the comment section. And if you are a student, please, I will circulate a form. Actually, there is a playlist for Big Data Engineer Immersion Active Students Live workshops. So whatever workshops that are covered so far are here. So you can go to this to get more details and insights about how it is typically taken care. That being said, thank you very much. Bye.